Dear students, in this video we are going to learn what do you mean by n-gram data structure and how it is useful for your information retrieval process. Now, what do you mean by n-gram data structure? It is mainly used in natural language processing after tokenization step. Now, the gram means what? What is the width of your token? It may be 1, then it is called as a unigram. It may be 2, called as a bigram. 3, called as a trigram. So, based on n is equal to 1, 2, 3 or whatever number, it is called as a n-gram data structure. Now, n-gram means what? The sequence of n items. It may be the characters, it may be the words, it may be the symbols. It is extracted from whatever text is available to you. It is used in natural language processing. What are the applications of this n-gram? For modeling your language, for generating the text, and mainly for our topic information retrieval. Now, it is a fundamental building block which understands how the text data is structured, means it is related using which pattern. Now, here listen, when I am writing the sentence as how are you, okay. Now, the question comes what will be the fourth word of my sentence? It may be a symbol known as a question mark, it may be today, it may be how are you feeling now, it may be how are you doing, it may be what is the meaning of how are you, and it may be how are you is known in Marathi. So, in Google, when you type how are you, then immediately you will get a drop down with all the possibilities of the sequence that is following how are you. So, based on the type of n-gram you are using, what will be the next probable word that is decided by your information retrieval system. So, here n is deciding you the types of your n-grams. When n is equal to 1, it is called as a unigram. It is not storing any history about the corresponding token. Okay. Now, it is the most basic representative unit, and how you are going to find out it? It is the probability of its individual one. It is not depending on anyone, so it will be the WI. Okay. That only token is giving me the probability. When n is equal to 2, then it is called as a bigram. Okay. Now, here I am considering the two consecutive words. The consecutive is most important. The words should be consecutive. The gap or the immersion of any symbol or the any other word is not allowed. Consecutive is important. Okay. Now, here how is the probability of WI is depending on given the probability of WI minus 1, the condition probability. Now, the trigram, that is a triplet, the number of words used in that token will be 3, okay, 3 consecutive words. Now, here the probability of your word is depending on the previous 2, okay. Now, how I am giving it? The count of WI divided by total number of the tokens. How I am giving it? The count of WI followed by means previous to it WI minus 1. Are you understanding? Means if there is a word as a natural language, then natural becomes a WI minus 1 and the language becomes a WI. And then I am finding all the sequences available in my storage, that is a WI minus 1 followed by the WI divided by the total count of the WI minus 1. Now, in the same way, the probability of WI is depending on the WI means the previous 2 words. How is the sequence? The WI minus 2 followed by the WI minus 1 followed by the WI and the count of what? WI minus 2 and WI minus 1. I am considering here. Okay. Now, let us consider one example. Okay. Now, when a sentence is given to you as I love natural language processing, then here what I am doing? I want a what I want? I want a unigram. Okay, what I want a unigram. Unigram means what? The size should be only 1. So then in that case, I love natural language processing. These are the individual unigrams. Now when I am going for the bigrams, join 2 together. It may be starting with the first one, I love, then love natural, then natural language, like that. Trigram, triplet. Consider the 3 words. Okay. Now, before going for n-gram processing, the tokenization is a prerequisite. Means before generating the n-grams, the text should be divided into tokens, that is the individual words or the characters. Okay, then only you can extract the n-gram. So n-gram is a representation of the tokens that you have generated. Now, what is the application of the n-gram? For language modeling, for the text prediction, for information retrieval, and for the text classification. Now, n-grams probability. How you are going to find out the probability of n-gram? Means how you are going to decide that word 1 will be followed by word 2 and what is the probability. Now, here we will see it more clearly with one example. This is my corpus available. Okay. Then from this corpus, I should generate one table. What are the different type of words available here? These are the 6 different type of the words. Then what is the frequency of each word that I am storing here? Okay. Now, what I want to find out, after do, what will be the word arriving? That probability I want to find out. Okay. Means what is the possibility that user is going to type next word for searching. Means what is user going to search followed by do. Okay. Now I want to find out do followed by the new words. Means how many words are here? 2 words. So it is a type of unigram, bigram or trigram? Bigram. Okay. Now how we are finding the probability of the bigram? The probability of wi given wi minus 1 is depending on the count of the wi minus 1 followed by wi and the count of wi minus 1. Okay. Now, let us see step by step. Now, we should see this example. Okay. Now, here what I am doing is I am considering the next word as I. So, let us consider the next word as I. Then in that case your wi and wi minus 1. Now what is your wi minus 1? Do. What is your wi? I. Okay. Now I want to find out the probability of wi minus 1 followed by wi, means do followed by I. Then in this corpus you check what is the count of do followed by I. So what are the counts? In these 2 places, do is followed by I. Don't consider I followed by do. Then what is the count of it? 2. Now what is the count of your do in your whole corpus? The count of do is 4. So this is the probability of do followed by I. Like this you should find out for M. Now when I am saying M, then in that case your wi becomes M and wi minus 1 becomes do. Okay. Then what is the count of do followed by M? Is there any sentence do followed by M? No. So 0 divided by the count of your do 4. So here you will get 0 by 4. Okay. Now Amit. Now what I want to find out? Do Amit. Okay. Now let us see. Is there any sentence where do Amit is existing? Yes, there is only one sentence. So here I am not having do, here I am having Amit. Now here I am having do Amit. Okay. Now here I am having do and Amit, but in between I and like are there, so I should not consider this. Here also I am having do Amit, but in between like is there, I should not consider it. So there is only one possibility divided by 4. So here what we will get? 1 divided by the 4. Now like, I want to find out do like. Now you should see, is there any combination with the do like? No. So, you will get 0 by 4. Now, next I want to find out do computer. Is there any word with the combination of do computer? No. So, 0 by 4. Now, do. After do, the last one is again do. So, is there any do? No. So, again 0 by 4. So, out of these all probabilities, which one is the highest one? Of course, the first one, that is the 2 by 4. So, the user will type after do I. So, like this n-gram which is constructed by using the condition probability is helping you to find out the next probable word. Okay. One second. Yeah, this we have covered. Now, what do you mean by n-gram smoothing? In some cases, what happens is I may not get the exact combination. I may be getting 0 probabilities for my combination, as we have seen in the previous example. So, what I am doing is I am adding some unseen symbols or the words. So, that process is known as a smoothing. Now, what is the drawback of your n-gram is when you are having longer sequences, when your text is of more length, then that longer sequence is not represented effectively with n-gram data structure. Okay. In neural language models, LSTM transformers are used to address these issues. In LSTM, what is happening? You are having memory cell which will store the previous results. So, in that case, it is useful. Okay. So, this is all about the n-gram data structure. Thank you.